Hello, 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 everybody, and welcome back. We're looking at question 23 now on the 2008 Fermat paper. Square PQRS has side length of 4 meters. Point U is on PR, so PR is a diagonal here, with PR, the total distance of the diagonal, being 4 times UR. Really doesn't look it on the picture. Maybe. Yes. Alright. Looks a little small, but you gotta remember the diagrams are not drawn to scale. They're meant as visual aids only, yada yada yada. Alright, anyway. The circle centered at U touches 2 sides of the square. Fantastic. We got this point here and this point here. Already I'm starting to think, well, I should connect these up by radii and I'll get right angles because they're points of tangency. Okay, this is, just important circle geometry connections to make. I don't even know if I'm going to need that for the question, but my instincts draw me there. And I'll draw it on the big picture as well. Tangent touches 2 sides of the square. PW, there's W over here, is tangent to the circle. So here's another point of tangency we're going to want to exploit. With W on QR. Okay, so we draw the point from we draw the line from P that lies tangent to this circle, and W just happens to be the point of intersection with QR. Okay, the length of PW to the nearest thousandth of a meter is. Alright, so once again, they say nearest thousandth or nearest tenth or to 1 decimal place, 2 decimal places. Automatically, we're reaching for our calculator. I'm not saying you can't do it without a calculator, but I'm not expecting in this question a whole bunch of, pi's and root 3's or like exact answers. I'm expecting at some point I'm going to have to... Well, with all these right angles, I'm maybe expecting a Pythagorean something or other, and I'll have to maybe take the square root of 59 or something like that. Or it's a grade 11 contest, maybe some trig, and at some point I'll have to figure out the sine of 59 degrees or something like that. Something inexact that I can't easily manipulate. And so that's when the calculator comes in handy. And that's really the reason to bring the calculator on these contests. They're allowed, but as I try and demonstrate, you can usually get by without a calculator, except for these approximation questions to the nearest thousandth meter, to 1 decimal place, that sort of stuff. Okay. Well, we've got a picture, and we've added to our picture. Let's see what we can see. We'll draw a bigger one that we can scuff up. So it's a square. I like that. Alright, so U is somewhere around here. Drawing the circle. Okay. And then we have this tangent. W, that's an R, that's a P, that's a U, Q was up here, S, I believe, is down here. Didn't really pay attention to what corner that is. Okay, so now what I'm going to do, I don't know, for example, things like the length of the radius. The only length I've got is that it's a square, so all the side lengths are going to be 4. What I'm going to do is, just like I did on the contest paper, I'm going to draw radii. Okay, so, I don't know, let's call the radius of the circle R. Now we've got these radii. We've got some right angles. We do have another right angle up here in the corner at R, and that means that U, I guess we could call this X and Y. U, X, R, Y is a square. Okay? And squares, if I know their side length, I can tell you the length of their diagonal. For example, PR is 4 times root 2. You can see that either by the Pythagorean theorem, or that might just be something that you come to know. Squares come up a whole lot. And similarly, UR is going to be root 2 times little r. But I know PR and UR relate. So PR is 4 times UR, despite the fact that it doesn't really look like it in the picture. So divided by 4 root 2 on both sides, we get a radius of 1, which means that this distance is 1, and then we go over by another 1, and another 1. Yeah, so we started. This circle takes up almost a quarter of the square. But knowing that, we can do two things. We can say, well, PU is just what's left over when we take off root 2r, which is root 2 times 1. So PU is actually going to be 4 root 2 minus 1 root 2, 3 root 2. And UW is r, which is 1. And they're not UW, silly me. Let's give a name to this tangent point. Let's say Z. So we got UY, or XY, and let's say Z. So that's UZ is 1. Alright, then PZ, there's a right angle in this triangle here at Z, so PZ squared is going to be UZ squared. Oh, no, PU squared is UZ squared plus ZP squared. And ZP is something I don't know. Do I need to know it? How will... I sort of got wrapped up in calculating things out. How will knowing PZ actually help me? Don't think it will. We want PW. How can I figure out what PW is? I never stopped to think about that. Okay, so PW. Well, what do we know about PW? PW is tangent to the circle. We don't have really anything else to work with. There is a right angle triangle here, PQW. So the tangent part to the circle doesn't especially help me. If I wanted PZ, that would be fine, but then there's this little extra bit, ZW, and I can't see a nice way to calculate that. That's my problem. It's the same as WX, but again, nothing that I'm particularly able to deal with. Okay. It's like I can't figure out WX. But what if we used a little trig, and maybe that's why it's asking for the nearest thousandth, because maybe we have to use a little trig. So we've got P, Q, W. There's a 4 here. If I knew this angle, that is to say, if I knew this green angle, then we'd have 4, so that's adjacent, so 4 tan green angle. Yeah, it's opposite and adjacent. Opposite over adjacent is tan of that angle, so multiply both sides by the adjacent, you'll get the opposite. Okay. So that works, and then... So that shifts the problem to, can I figure out the green angle? Maybe I can, maybe I can't. But the green angle is going to be this angle here, which it's one side to the diagonal, so it's going to be 45 degrees, minus this angle in here, and I know enough about this triangle, because I've got 1 and I've got 3 root 2, that I can figure this out. Okay. So let's give some names. Let's call this theta and this phi. So, again, doing a little trig. So this is hypotenuse. This is opposite and adjacent. So sine of phi is going to be 1 over 3 root 2. Not something I recognize, so I can't easily figure out what phi is, either in radians or degrees. But theta is 45 minus phi. And we want 4 times tan theta. So that'll be 4 times tan 45 minus theta. Now, I would like to say, I think you can actually, if you know enough trig identities, and sadly they're failing me right now, but I know you can do sine of something minus something, and you can expand that out, and you can do cos of something minus something. And I know there's one for tan, I honestly can't think of it off the top of my head right now. It doesn't come up very often. I think it's tan of A plus B is tan of A plus tan of B all divided by 1 minus tan of A tan of B. I think that's what it is. But I don't know off the top of my head. I'm not going to pause the video and look it up. You don't have that luxury on contests. So what I'm going to do is I'm just going to say, okay, this is enough information to grab my calculator. But I think this probably could be done exactly. And it'd be interesting to try and do it exactly. Nice little indicator to me that maybe I should brush up on my trig identities. But this is enough to figure this out. So what are we going to do? Well, we'll do 1 divided by 3 root 2 is about 0.2357. That's cool, first 2 primes. Okay, I'm going to do arc sine of that, or sine to the minus 1 if you'd rather. So phi is sine to the minus 1. Another way to write that is arc sine. Yes, they both mean the same things. Why do we have 2 different ways to write the same function? It depends on the context, how clear you want to be. Arc sine's nice, but it has a bit more writing. Sine to the minus 1 is short, sweet. It makes a nice connection to standard inverse functions. The inverse of f is f to the minus 1. But it also gets confusing because we tend to write sine to the 2 to mean sine squared, so shouldn't sine to the minus 1 be 1 over sine? Well, no, that's cosecant. That's a completely different function. Anyway, just getting you used to, I don't know what your calculator would say, so I want you to be prepared for either symbol. So, phi there is 13.63302223. Just writing them all down. Okay, so we want to do 45 minus that. Yada, yada, yada. So it'll be 31 point... 31.366977777. Okay. And we want 4 times tan of that. So that'll be, and then we press tan. I get 0.609 something, multiply that by 4, and I get 2.438447, and that seems a little low. Yeah, none of my answers are that low. So what, if anything, have I done wrong? Okay. Is it not 3 root 2? Or is it not 4 times this angle? Sine is opposite over hypotenuse. But 13 degrees seems a little big for this phi right here. So should it be smaller? Opposite, adjacent, hypotenuse, sine SOHCAHTOA. One divided by 3 divided by root 2. 0.2357. Sine inverse of that. Okay, and then tan of 31.33 something or other. Multiply by 4. What in the world am I doing wrong? Side length is 4 meters, sure. Point U is on PR. So that UR, 4 times UR is PR. Well, PR is 4 times root 2. So UR has got to just be root 2. And that means that each of those radii is 1. There's no way around that. I feel like they're just... I mean, I know the diagrams are not drawn to scale, but I feel like there's something I've missed horribly. PU is 3 root 2. UZ is just the radius, which is 1. I see. I see what I did. Okay, I figured it out. I didn't miscalculate. I'm not shooting for PW. I'm not shooting for QW, which is what I was just solving for. Doi. Okay. So we don't care about tangent. We want the hypotenuse. I honestly cannot think of why I did QW. Must have just absolutely slipped my mind. Okay, so I want 4 times... No, wait, what do I want? Okay, Ka. Adjacent over hypotenuse is cosine theta. So the hypotenuse, PW, is A over the cosine. There we go. I was solving for the wrong thing. Okay, so we don't want that. We want PW. Always read your questions carefully. Well, no, I guess I did read the question carefully. I just absolutely flubbed the diagram right there. Started solving for the wrong thing. Okay, so 4 divided by the cosine of 31.3669777. A much better answer. Okay, so it'll be 4.6846. I don't need to keep going because it was to the nearest thousandth or something like that. So we round up and we're going to get C. Because the 4.6 rounds up to just a 5. And there we go. Now, I didn't need tan of 45 minus phi. So can I actually get an exact answer? I wonder if I can. I'm just going to... So despite the fact that I sort of flubbed the video because I kind of started solving for the wrong thing, I did eventually get the answer. And, life lesson, this can happen to any of you. But I'm actually going to see if I can get an exact expression, not just calculator. Obviously, if I get something like, 4 root 7 minus 2 root 3 plus pi, I would need a calculator to figure that out and figure out which answer is correct. This is more of a challenge. Can I remember my trig enough to do that? So that's what I'm going to do. If not, if you're not interested in watching me do that, and frankly I wouldn't blame you, feel free to just jump to the next video. So that'll be question number 24. But stick around if you want to just see me muck about with a little bit of trig. So I know sine A plus B is sine A cos B plus cos A sine B. I want, so cos A plus B is cos A, cos B minus sine A sine B. Now I wanted 4 over cos 45 minus phi. So that's cos 45, something easy to figure out. Cos of negative phi. But cosine is an even function, so this will just be cos of phi. Minus sine 45, again, something pretty easy to figure out. Sine negative phi. Okay, so that's root 2 over 2, same as cos phi. Now the minus here and the minus from inside the sine will pop out and become a plus. Okay. Now, I know that sine of phi is 1 over 3 root 2, and cosine of phi is going to be the square root of 1 minus this thing squared, so that'll be 1 minus 3 squared is 9, root 2 squared is 2, so 1 over 18, so this will be square root of 17 over 18, a yucky, yucky number. But there we go. What do we want to do? Let's call it root 17, 3 root 2. Now, ultimately, our answer was PW is 4 over cosine of 45 minus phi. So that'll be 4 over, we can take the root 2 over 2 out, and it'll be 1 plus root 17 over 3 root 2. I'm going to cancel these 2 root 2's. The 2 and the 3 can come up to the top, so it'll be 24 over 1 plus root 17. And let's just check on a calculator. Is that what we've got? So 24 over 1 plus square root of 17. Exactly correct. Okay. So you could do it nice and exact. And I know one mathematician will be very happy because there's a 17 here. But there we go. So you can do it exact. Not so bad. And you could have done, I guess I was trying to solve for QW earlier. You could do that exact as well if you knew the appropriate tan law. Alright. But that does it. And as I've said before, I'll see you guys in the next video for question number 24. Until then, take care.